Welcome to two-dimensional numbers, which is complex number. So in this lesson, we're going to cover why we need complex number, what's behind complex number, what's the reason complex number. We'll see those, and what's the use of complex number, and so on. So let's directly go to the discussion. So as you know that natural number is start from 1. So we have 1, 2, and so on. So this natural number, when it includes 0, okay, that gives us a whole number, right? Whole number. Again, if we include negative here, -1, -2, -3, if we include negatives, that leads us to integer. Okay, we have whole number, now we have integer. Okay, integer. And then integer, for example, if we solve a problem with fraction, 2/3 or 5/3, we can't have fraction in integer. Therefore, we have to have another number. We have to extend our thinking of number to rational number. Okay, so we start from natural number. There is a situation where natural number doesn't include zeros, so we need 0 for placeholder, and then we continue our thinking of numbers to whole number. Okay, again, whole number doesn't solve a situation where that involves negatives, like temperature. So in this case, we have to think more about more numbers. That's integer. Now we are in rational number. Still, there are situations where square root of numbers are involved. There are situations. For example, if you solve quadratic function and then if you get the square root of 2, we don't have the square root of numbers, especially the square root of 2 in rational number. Of course, we do have for the square root of 4. Okay, non-perfect squares. So we have to think, we have to extend our thinking behind rational number. Okay, I'm behind integer to rational numbers. So our numbers again goes to another types of number that includes terminating, okay, non-terminating. All right, so 2.311, just like pi. All right, these numbers are included under irrational number. Okay, it goes to irrational number. You see, the circle is getting bigger and bigger and bigger. Now we have irrational number. So these two last circles, rational and irrational, is included under a huge number. Okay, that's called, we're just revising real numbers. Okay, let's represent that as real number. So we have here real number, the union of rational and irrational. So real number is the biggest number that includes all of them. But the problem is, real number is not the end to solve any kind of real life problems. For example, when you solve some kind of quadratic function, let it be x squared plus bx plus c is equal to 0, and then after you solve, and then you get, let it be minus b plus or minus the square root of, let it be negative number, okay, over 2a. So in this case, you're stuck. In a real number, you can't solve this one. So you are going to say that it is meaningless. All right, so your solution set will be meaningless or empty set. Real number can't solve this problem anymore. So there is a restrictions. So in real number context, the square root of negative number, let it be -2, is meaningless. We use the word meaningless. All right, or undefined. All right, we can't define the square root of negative number. The reason is, let the square root of some number b is a. Okay, if you score a square on both sides, all right, if you square on both sides, you will get a squared is equals to b. So let's take a is greater than 0, which means a is positive. So the square of the positive number is positive number. Still, in this case, you will get the value of b as a squared. All right, let's take again a is negative number. Okay, so still when you multiply any negative number, all right, by itself, all right, negative times negative is positive, you still get a squared. This is the same as b squared. So in both cases, whatsoever the number, when you squared it, it is positive. You never have negative numbers. But the problem is you can't have the square root of negative numbers. You're stuck here. You can't solve any real life situation in real number here. So mathematicians extend their thinking to more than real number, which is called complex number. Complex number. All right, you know what they did? They just imagine that let's the square root of a negative number, let it be the square root of, for example, negative 3 is the same as the square root of negative 1 times the square root of 3. All right, this is by the principle of the square root of a times b is equal to the square root of a times the square root of b. So let's imagine that this is I. All right, so iota, which is an imaginary number. Okay, they imagine this number, imaginary. Okay, they just assume that the square root of negative number has to exist. So they bring from non-existence to existence. Okay, therefore, for example, if you are given negative 4, the square root of negative 4 in complex number, that's the same as negative 1 times 4. So the square root of 4 is 2. All right, you have 2, the square root of negative 1. This goes to 2. We already said I, all right, is the square root of negative 1. So we can represent that as 2i. So we develop another planet for a number whose square root of negative number has meaning rather than non-meaning, or rather than undefined. Therefore, why it is two-dimensional though? It is two-dimensional. Okay, as you know, real number is one dimension. Okay, real number is one dimension. We can represent a number on a number line. That's why a line is one dimension. So we just took that as the dimension of real number. So you have here 0, 1, 2. You have also negative. You have here half, 1/2. Okay, between these two, 1.4. We have the square root of 2, and so on. So we can represent a number on a number line, real number on a number line. So that goes to one dimension. One dimension. That is, it has, let it be length, right? It has length. Line has length. It is a one dimension. So when we bring another here, let it be the y-axis here, okay, the y-axis, and then we are going to represent that as, for example, 3 here. So we can take this as imaginary part. Okay, you can bring this to like, okay. So if we take any number here, okay, let it be I, just for clarification. So if I take any point here, all right, that's going to be, for example, I have here, and I have here 2i. Okay, let it be, I have this too. So it is a combination of real number and the imaginary number. So this is a y, and this one is an x. All right, so we can represent complex number on a plane. Plane is two-dimensional. Okay, so if, for example, if I give you, if I give you 2 from real number, and 3 from complex number, I mean from imaginary number, this is imaginary number, we can represent this. The first one is x and the second one is y. So we can definitely put this on the x-axis and the y-axis. Okay, so this means it goes 2 units to the right, 1, 2 units to the right, and 3 units up. Okay, let be 1, 2, 3 units here. This is the point. This is 2, 3i. So for example, if we take this line, so we have this complex number. We can represent complex number on the xy axis. All right, so let's go to the function complex number. In addition to solving those problems like those quadratic function, which we just simply say input say whenever we get under the square negative number, it also has a huge implication even in engineering. Okay, even engineers, a very practical breed, have found use of complex numbers. When Michael Faraday discovered alternative current in 83s. Okay, of course, imaginary numbers gained a physical reality. In this case, the letter J was used as the symbol to represent complex number, the symbol for the square root of -1. Because at that time, I belongs to or stands for electrical current. Okay, it was represented by electrical current. Okay, current. And it has any other implication in the other subjects too, in addition to solving those problems that we can't solve in real number. Just like any other number, we can add complex number, subtract complex number, divide and multiply complex number.